Right. Okay. So everyone, just when I started, okay, let me get the lights on. So, um, yeah. So today in our lesson, we're going to talk about the distributive property. Okay. Not surprising. I think you know where that's going. And then we're going to distribute, combine like terms together, and then hopefully I could squeeze that into the 12 minutes. Is to distribute, combine, and then solve an equation. Okay. And then now, if you in the 10 minutes, if you don't get it immediately, that's fine. We're gonna spend a couple of days on it, so don't worry too much about it. Okay. All right. We got time. So okay. All right. Let's start. Okay. All right. So we're gonna talk about the distributive property. All right, which should not be strange to you at all. All right, because you must have spent some time last year doing this. The question really is, how deep did you guys go with the questions? All right, so that's what we're about to explore. So okay, all right. So now, the way I want to do this is to take you from a sixth grade perspective all the way to a high school perspective. Okay, within the next 3 days. All right, the next 3 school days. Okay, so we're gonna start off with the super duper basic notion of what this distributive property is. Okay, so let's take a look. Now, here we have a hexagon, right? And we know that this is a hexagon because it's got 6 sides. And not only that, here we got a regular hexagon because we got 6 equal sides, right? Now, here's the question, right? How do you find the perimeter of this shape, right? I'm sure many of you will say, Mr. Ng, you just add all of these up, right? So if you add all of these up, that will give you a sum, right? That is going to be an expression that will reflect the perimeter of the figure. Now, that means you might have to do something like this, right? I mean, I think you already see where this is going. So on and so forth, right? But that's inefficient, to say the least. What's a shorter way of doing that, right? Yep, it's got 6 sides, right? So we do 6, 9y plus 1, right? And then we'll have our simplified expression. I wouldn't say that's the answer, but simplified expression. So 9 times 6 is 54. 54y plus 6, right? That would be the expression, right? So that's the birth of the distributive property, right? So having said that, right, we're gonna distribute again. Okay, let me see if I can use my rainbow marker. All right, a fan favorite. So here we're gonna distribute. All right. If you guys ever seen a very viral video from many years ago now, all right, there's a guy who saw a double rainbow and then he cried and completely freaked out. All right, and then he said, "Double rainbow, what does this all mean?" Okay, so that's what the double rainbow is for you guys. All right, now. So here now, I think you can see I'm right off the bat. I'm not even spending time distributing anything else other than a fraction, okay? Because again, this should be nothing new. So here we have 1/2 times 2x, right? Let's write that out on the side here somewhere. So here you gotta watch out, right? Because here you technically, if you really multiply it, right, you get 2x over 2, which really is just 2 over 2. That's 1, right? That gives you the x, right? You don't have to do that. You can just cancel them out like that, like so, and then you're just left with x, okay? And I did that on purpose, by the way. All right, 1/2 times 6, what's half of 6, right? 3, right? It's positive 3. So I got the sign here, positive 3. So the answer is x plus 3, right? Okay, let's try another one, all right? 1/3, oh, oops. That's my fault for not using the double rainbow pen. See, if you guys were in class, I'll let you come up to the board and do this. And I know you guys are old, sophisticated 8th graders, but no one has ever looked at a rainbow pen and not want to use it in class. So, just saying. Now, 1/3 out again. We'll do that here. 1/3 times 9x, right? You can cancel, right? 3 going to 3 once. 3 going to 9 3 times. 1 times 3x. 3x. 1/3 of positive 12 is what? Yep, positive 4, right? Okay, all right, let's do one more. Actually, I want to show you some negative numbers. So let's show one more and then I'll show you some negative numbers. Again, let's go to the rainbow pen. All right. What does this all mean? Okay, all right, so 1/5. Now, you see this placement of a negative number here, all right? That is not by accident. So 1/5 times negative 10x. What do you think that would be? All right, 5 going to 5 once, 5 going to 10 twice. Now, don't forget the negative. So that's 1 times negative 2x, negative 2x, right? 1/5 of negative 25. What's a fifth of negative 25? Yeah, negative 5. And that's it. Okay, so let me show you a couple more examples. And then I want to show you distribute, combine, and then solve. How we're doing on time. We're 6 minutes, right? Oh, not even. Good, good, good. Okay, all right. Now, let's try this one. What happened? Okay, all right, well, it didn't work temporarily. Okay, so now this is tricky, right? You got to be careful. So negative times negative, I know the answer is going to be positive. Okay, I'm writing it just to remind myself. Now, 3 times 1 is 3. 8 times 5 is 40. X, don't forget that, right? Negative times positive. Negative. 3/5 times, 3/8 times 4. So let's do that on the other side. 3/8 times 4, 4 going to 4 ones, going there twice, so that's 3/2. You can keep it as such. So 3/40 x minus 3/2. Okay? All right. Now let's try one more. What's a great question to try? All right, I want to try 5 and 7. Oh man, all these are good questions though. Okay, all right, doesn't matter. So I'm going to skip 10, all right? If you want to try 10 on your own, be my guest. Number 6. Number 6, what do you think is the only thing you got to do that's different? Yep, turn that into an improper fraction first. Okay? All right. 7. Now, I want to really talk about 7. It's very important that we talk about 7. So look at 7, right? If you're looking at 7, now, here's the thing, right? You might say, hey, Mr. Ng, use your rainbow marker and then distribute. But here's the big question. All right, big question. What am I even distributing here? Right? I mean, look at this. What am I distributing? There's no number here. Like, what are you talking about, Mr. Ng, right? But I'm going to rewrite this, right? Remember, if there's no number here, right outside of a parentheses or even like a variable, right? So let's say I got negative x, right? What number is actually here? That's invisible. Right, 1. So if I were to rewrite this, this is the actual question. See that? So now I'm actually distributing the negative 1. Okay, and now I'm going to show you a shortcut, okay, for this. Now, negative 1 times negative 3x is positive 3x. Negative times negative here, that's positive. 1 times 5/3 is, of course, 5/3. Shortcut time. If you see a negative number like this and nothing else, you can just switch this. So imagine it's almost like turning your lights on and off, all right? When you enter like a room or something, right? It's a switch. This is basically like a switch button, right? It's saying, hey, whatever you're doing, switch it. So what does that mean? The negative becomes positive. The negative becomes positive. Look, same answer. That's all this is, all right? But it only works if there's a negative sign and nothing else, okay? That way you can switch everything inside of parentheses. Now, this last one, how is this one different from the rest? Well, there's a fraction at the end, but it doesn't matter. Just rewrite it. Like that, and then you would turn this into 9/4. You turn that into 4/3 x No, there's no x there, oops, minus 3x, right? You can cancel these, all right? Again, that's done on purpose. 3 minus 3x, right? Or negative 3x plus 3. Okay, again, I get the sense that I'm going really, really fast. If you want to do 9, by the way, be my guest. I'm going really, really fast because this is all review. So if you want to slow down, press pause, go back and redo this question and see how I got the answer. Okay, but that's on you. All right. Okay, next. Yeah, we're reaching 10 minutes, so I think I can do 2 more. Okay, all right, that's fine. If not, we can do it in class. So, okay, distribute and combine. So what does this mean? Distribute, right? So that's 4 times 3x, that's 12x. Positive, 4 times 4 is 16, minus 2x, right? OMG. What topic is this? Yeah, combining like terms. What are the 2 different families? Yep, the 12x and the negative 2x, right? And then you got 16, that's in a number family. 12x minus 2x is 10x plus 16, and there you go, simplest form. All right, let's do a couple more. I don't even want to do these anyway. Too easy, too easy, too easy, too easy. Try this one, right? Negative, right? Remember what I said about the switch, right? Switch that to a negative. Switch that to a negative, right? Or otherwise you can distribute the negative 1 here, right? What about this one? Likewise, same thing, right? So negative 1, turn that into a positive 5x. Now, if you want to rewrite this in more standard form, you can write 5x minus 1. Okay? All right. Now, this is actually what we came to do. So watch this, right? This one, right? Distribute, combine, right? So look. Now I got to distribute. Don't distribute the 6, okay? The 6 has nothing to do with the multiplication. Like, this is all the way out there by itself. So I got 9, right? So I'm going to rewrite the whole thing, right? Why? Because all the cool kids do it. So 9 times 8, 72. Positive 9 times negative 2b, that's negative, right? Positive times negative, 9 times 2b, 18b, okay? OMG, what topic is this? Yep, combining like terms. Who's in the same family? Right, the number family, and then this is by itself. So I'm going to rewrite this first, because as you may well know already, letters come first, okay? Negative 6 plus 72 is what? Yep, positive 66. Okay, how are we doing on time? Ay. All right, one last one. Okay, so distribute this. All right, so that's negative 2n plus 18 plus 4, right? Families. So this is by itself, so that stays. Combine like terms. There you go, and that's it. Okay, all right, I kept it under 13, okay? So, all right, thanks for watching, and I'll see you guys in class. Bye-bye.
OMG, that was so good.